solid formed by revolving the region bounded by the graphs y equals x squared plus 1, y equals 0, and e equals 1 about the y-axis. And I've drawn that here. This in green is x squared plus 1, y e equals 0 is just this axis, and then x equals 1 is this vertical line. The region is shown right here, shaded in black, and it is being rotated about this y-axis. So, to find the volume is the integral of any area dx. And our bounds will be where these two lines, where from 0 to 2, because these two lines meet at 2. So let's just do 0 to 2 for us. Now, the area of anything in a circle, because this is being rotated in a circle, is pi, let me write this here, pi r squared. Now, because there are two graphs, we have to do another minus pi r squared. Okay? Our outer radius of this circle, of this shape, will be x equals 1. So, let me write this again over here. And I'm going to factor out this pi. We have one radius minus another radius squared. It's equal to, the first radius is just 1. We're squaring that. Subtracted by another radius squared. Now that other radius is this graph. However, because we are rotating it about this y axis, we have to change this shape a bit. So we start with y equals x squared plus 1, but we have to get it in terms of y. So we have to isolate x. For this, we subtract 1, and then we square root both sides, so that x is left alone. So this is our new modified radius to input right here, the square root of y minus 1. So we then, this, by the way, because this is our because this is our area, we can integrate this directly. Dy, that's supposed to be a y, between 0 and 2. I'm going to rewrite this with some more room. We'll be right back. And we're back. All I did was move the thing from the bottom here to the top, so we have more room to work with. So we have to evaluate this. What I'm going to do at the very start is move any coefficients out, because we will not need them till the very end. And so pi can go from being inside to being outside, right here. Integral from 0 to 2. Let's evaluate 1 squared. That's just 1. Minus, and then let's evaluate this. This, we are squaring a square root. So anything that's on the inside just comes out of that. It's really cool. Now, this is where we have to be a little bit tricky. One might think to just remove these two, and then we have 1 minus y minus 1, 1 minus 1 is 0. However, you have to distribute this to both of these. So you would have, I'm going to rewrite this, distributing that minus sign, 1 minus y, because this y is positive inside of here, plus 1, because this one in here was minus, and minus and a minus make a plus, dy. So now, this can be rewritten as pi times the integral of 0 to 2 minus y dy, because you're adding this one and this one. So now, this is where we want to work with. This is really easy for us to use. The integral of 2 in terms of y is 2y minus, and then y is y squared over 2 between 0 and 2. And now we just plug in our values. I'm going to plug in up here. So if we plug in 2 I, so we get 2 times 2 is 4. 2 squared is 4, divided by 2 is 2. We just get that. And then we plug in this 0. We have to subtract every terms that we do with the 0. 0 times 2 is 0. Okay, cool. 0 squared is 0. Over 2 is 0. 0 minus 0 is 0. So when we solve that, we get just 2 pi. This is the area. This is the volume. Sorry, this is the volume of this shape in there being rotated about the y-axis.